Welcome to the last video of the first unit. I can't believe we're already through one unit. So, last thing we're going to look at are pairs of angles and some special names that we'll refer to them as. These things, again, these will come up over and over this entire year. Everything in this first chapter is going to keep coming up. You're going to want to know them, obviously for the test, but then for the rest of the year. So, we're going to identify adjacent, vertical, complementary, supplementary angle pairs, and find measures of pairs of angles. So, pretty simple to start, and then we'll look at some more complex word problems at the end. Adjacent angles, two angles with the same vertex and one common side. Think about adjacent neighbors would mean next to you. So all that means is if we had two angles like this, 1 and 2, those are adjacent to each other. They're next to each other, they're touching on one common side. A linear pair, look at the word line, is a pair of angles, pair of adjacent angles that actually form a line, or we would call it a straight line. Basically, they form a straight angle. We know that this would be 180 degrees. So 1 and 2 are a linear pair. So if you knew 1 was 100, you then know 2 is 80 degrees. Vertical angles, these come up a lot. We had something like this. Two non-adjacent, so not next to each other, angles formed by intersecting lines. They are always congruent. So that would be like this. 1 and 2 are congruent. 3 and 4 are congruent. Okay, so they are always congruent. So if 1 is 80, 2 is 80. If 3 is 60, 4 is 60. Pretty simple. Okay, so just going through making sure we're able to do these. Excuse me. Tell whether the angles are only adjacent, adjacent and form a linear pair, vertical angles, or neither. This is where I'd like you to pause it, work ahead, and then see if you got it right. It's not going to do you any good to just listen to me give you the answers as you work. So try them and see how many you can get right out of these 5. I should also tell you, I guess, that angle 4 or angle 3 is supposed to be an angle 4. So we have angle 2 and 3. They're right next to each other. Okay, so that's important. So they're for sure adjacent. Do they form a linear pair? No, there's not a straight line as like their base. They're not vertical angles because they're next to each other, so they have to be just adjacent. Okay. Angle 3 and 4, which are right next to each other again, so for sure they're adjacent. And now look, they form a linear pair because they're on a straight line kind of as their base right here. This straight line is going to let them form a linear pair. So adjacent, so we'll just call it, actually, we don't need to call it adjacent linear pair, we'll just call it linear pair because we know those are adjacent. 1 and 2. Okay, now if we look at 1 and 2, this is where people get a little bit mixed up. 1 and 2, clearly not adjacent because they're not next to each other. So they can't form a linear pair. They're actually not vertical angles. Vertical angles, again, look like intersecting lines. If you look at this line coming through here, and this line coming through here, angle 1 and angle 2 actually don't have these intersecting lines. Now they have sort of crossroads going all over the place, so it's a little bit different when you look at those. Okay, so angle 1 and 2 are neither. Then if we look at 1 and 3, now we do have intersecting lines, and you can clearly see that those are vertical angles. And QXR, okay, so this angle here and angle 4, again, they're obviously not adjacent, so they can't form a linear pair. Vertical angles, this side coming from up here goes right through here. Okay, so it's it's actually not a vertical angle because this is the side that makes up angle 4, and this is where it's cutting through. So it does not make vertical angles. So again, it's neither. So it's a little bit tricky with vertical angles. Hopefully you got 5 out of 5 if you worked ahead. A couple different kinds of ways we'll talk about angles in comparison to each other. Again, pretty simple. Complementary angles, just make sure you know which one's which. Any two angles whose measures have a sum or add up to 90 degrees. So we'd have something like angle 1 and 2 are complementary. If angle 1 is 30, angle 2 is 60. Pretty simple. Supplementary, let's see. Oops, I don't want to draw that. I want to draw this. Basically, supplementary is pretty much like a linear pair. It's the same idea. Any two angles who have a measure of 180 degrees together. So angle 2 is 160, angle 1 is 20. You guys get that. Way to remember, between the two, 90 is smaller than 180. C comes before S in the alphabet. Whatever works for you, just make sure you know the difference between complementary and supplementary. Here's another good spot for you to work ahead. Pretty easy stuff to work through. If we have some angle, we know complement makes it add up to 190, supplement adds up to 180. So if we have an angle that's 80 degrees, its complement is 10 degrees. Its supplement would be 100 degrees. See if you can work ahead and even get to 2x minus 12 and try that one. So I'll let you pause and work ahead. Okay, next one would be 55 degrees. So if you're doing that, it would be 90 minus 55 equals 35 degrees. Again, not too bad. 180 minus 55 equals 125 degrees. We have 17, so 90 minus 17 is 73 degrees. 180 minus 17 is 163 degrees. We have x, so it's 90 minus x, you're done. 180 minus x, you're done. You can't do anything else. So it's the same idea here. So you're going to have 90 minus 2x minus 12, 180 minus 2x minus 12. Same idea, you could actually simplify it if you wanted and distribute, kind of like there's a negative 1 here, distribute that in. So you're going to end up with 90. Actually, let's write it down here. 90 minus 2x plus 12, or we would say that's 102, add up 90 plus 12 minus 2x. And same thing here, we're going to go ahead and distribute like a negative 1 in. 180 minus 2x plus 12, so you're going to have 192 minus 2x. Okay, same idea, just simplify at the end. You're subtracting in your head, put a little algebra in there, not too bad. Looking at a couple of examples, see how well we can do with everything we just talked about. So vertical angles, linear pair, we need to be able to use all of it. So find the measure of angle OBT. So OBT is right here. We need to be able to find that angle. Now, you're not always going to be able to find the angle you're looking for right away, so you'll have to start in other places and work towards it. There's multiple different ways to do these. Work with whatever way works for you. See if you can work ahead and solve this, and then go back and check your answer. So, we have, first thing we can look at, we know that this angle and this angle form a linear pair. They're supplementary. In other words, they add up to 180. Or we could go with this angle, this angle. That's vertical angles. They're congruent. You need to be able to find x somehow. Once we have x, then we can work with something and figure it out. I'm going to go with vertical angles because I like them. They're easy. So 3x plus 5 equals 4x minus 22. Subtract 3x from both sides. oops, 4 minus 3 is not 4, it'd be 1x. And then add 22, x equals 27. There's x. Now again, we want this though, OBT. Okay, well, we need to find OBT. There's no expression there, so I can't plug it in. Think about what you could do. You could plug 27 in here, and then use vertical angles. You could plug it in here, and then use linear pair. Here, use linear pair. Again, there's tons of ways you can do these problems. That's what's nice about geometry. There's different ways you can think about it, different ways you can try it. I'm going to use vertical angles again because I like it. So I'm going to say, okay, x plus 67 or 27 plus 67 is going to be equal to, it's going to give me 94 degrees for measure of angle OBT. Okay, so this angle is 94 degrees. We can find the other three angles if we wanted to as well. That's the only one I'm asking for though. Next one, looking at a couple angles. We want to just solve for x. So you don't have to find anything after that, just solve for x. So we're looking at this key feature right here. Right away it tells us it's 90. Again, this is one that you can probably work ahead, see what you come up with. Okay, hopefully you're checking your answer. We have x plus 12 and 3x minus 2. Little plus little equals the big, and we know the big is 90 because they're complementary angles. They complement each other, they add up to 90. So, pretty simple. X plus 12 plus 3x minus 2 equals 90. So we have 4x plus 10 equals 90. 4x equals 80 after you subtract 10 from both sides. X equals 20, and we're done. Example 5 is going to give us one more actual diagram problem to look at, and then we're going to look at some word problems that are a little bit more difficult. So, solve for x, and we have an x. We also have y's here. Anytime you see x's and y's in geometry, it probably means you're going to need to set up a system, which is why we practice systems so much. So, we have a couple of things going on here. This tells us that that's 90 degrees. So, pretty easy to start with. We can set up one equation as 9x plus 18y equals 90. We need to come up with another one to create a system. Right now this is not a system yet. If we know this is 90, and we know this is a straight angle, we also know that this is 90. 90 plus 90 is 180. They create a linear pair together. So our other one would be these two combined. Now, we have to combine them a little bit first. 7x minus 1 plus y plus 60 equals 90. So we have to make it 7x plus y plus 59 equals 90. And then subtract to go ahead and get it. So you have to make sure it's in the same exact format. Oops, 31, not 41. Right, now we're good to go. xy equals your number, xy equals your number. So just combine like terms, move things over so you get your numbers on the other side. Come up with something you can multiply top and bottom by, or top or bottom, doesn't matter. Multiply the bottom by negative 18. So we're going to have 9x plus 18y equals 90. On the bottom here, we're going to have, let's see, 18 times 7 is going to give you negative 126x plus, or minus rather, 18y equals 18 times 31. Let's see what that gets us. Negative 558. Okay. Add straight down. So we're going to get negative 117x. These cancel, which is what we want, equals, let's see, that's going to give us negative 468. Divide both sides by negative 117. And we're going to get 4. Okay. And you're done. So again, start with a system. You see x's and y's, you need to come up with a system. Okay, let's look at some word problems. I know people freak out when they see word problems. Follow these steps and you'll be just fine. So, when only the complement or supplement is mentioned, so one or the other, not both, just draw a picture. Simple as that. Draw yourself a diagram. Two angles are complementary. That should tell you right away they add up to 90. One angle is 8 times the other angle. Alright, well, let's first draw what this is looking like. Okay, we have two angles here. One angle is 8 times the other angle. We don't know what the other angle is. If we knew it was 10, we could figure it out, but we don't know what that other angle is. Anytime we have an unknown in algebra or geometry, we use an x or y or whatever letter you like. So now we can say, okay, one angle is 8 times the other angle. Well, if this angle is x, this angle is 8x. Okay. So what that's going to tell us is 8x plus 9x, or 8x plus x equals 9x, or 8x plus x equals 90, sorry. So 9x, there's where our 9 came from, equals 90. Divide both sides by 9, x equals 10 degrees. Again, x is 10. Is that the answer, though, to the question? Find the measure of the smaller angle. Okay, in this case, x is 10. The smaller angle is just the x. So it is 10 degrees. Okay. Here's one with supplementary. So again, right off the bat, thinking 180. Two angles are supplementary. One angle is 5 less than 4 times the measure of the other angle. Find the measure of both angles in this case. Okay, don't panic with all the words and 5 less, 4 less, all that stuff. Draw yourself a picture. So we have two angles that are supplementary. They form a linear pair. One angle is 5 less than 4 times the measure. Again, here's that word, other angle. We're not sure what the other angle is, so give it an x. It doesn't matter which one's which, because we're just putting a diagram together. So, one angle is 5 less than 4 times the small. So, in other words, we'd say 4 times the measure of the other angle. So, this angle is 4x, but it's subtract 5. It's because it's 5 less than 4 times the small. So it would be 4x minus 5. It wouldn't be negative 5 plus, well, you could do negative 5 plus 4x, but it wouldn't be 5 minus 4x. That wouldn't make sense. That'd be saying it's 4x less than 5, which obviously doesn't make any sense. So now we can go ahead and set up an equation. 4x minus 5 plus x equal 180. 5x minus 5 equals 180. 5x equals 185. So x, if you divide both sides by 5, is going to get you 37. So there's x. That gives us this angle. Plug it in for your other angle, so 4 times 37 minus your 5 is going to get you 143 degrees. Or you could have done 180 minus 37. Both work. Okay, the last word problem we're going to look at is going to involve complement and supplement at the same time. Don't try and draw a picture, it's going to screw you up. So if just complementary or supplementary are mentioned, go ahead and draw a picture. If both are mentioned, we're going to use this method here. Okay, so example 8. We'll do this one together. Tomorrow we'll have the 9 and 10 done in class. The measure of a supplement of an angle is 3 times the measure of its complement. Find the measure of the complement and supplement. Okay, a lot going on. First, keyword in math. Anytime you see is like an equals. So highlight that important word. That's going to help you set up your equation. Once you have your equation set up with these, they're not bad. It's algebra. You got to set up your equations though. So the measure of a supplement of an angle. Okay, well if we look back to this chart we did, any supplement, so any x that we have here, so if something was 60, we could do 180 minus 60, or if it was 70, 180 minus 70, whatever it is, we're going to take 180 and subtract out x. If we look at this problem, we don't know the measure of a supplement. So what we're going to say measure of supplement is 180 minus x. We don't know what it is. Okay? So now work your way across these words. The measure of a supplement of an angle is 3 times, so we know we're multiplying, 3 times the measure of its complement. Complement's the same idea as our supplement. If we look at this table, 90 minus x. Okay, so if we had 40, 90 minus 40 is 50, whatever it is. If we don't know what it is, that's why we use 90 minus x. So it's going to become one big equation. 180 minus x equals 3 times 90 minus x. Solve it. 180 minus x equals 3 times 90 minus x. 180 minus x equals 270 minus 3x. We'll go subtract 180 from this side. Negative x equals 90 is 3x. Add 3x to both sides. 2x equals 90. So x equals 45. That's just part of it. Now we want to find the measure of the complement and supplement. Alright, so x is 45, key part. So complement's going to be, oops, I don't want to do equals. Complement's going to be 90 minus x, or in this case 90 minus 45. Supplement is going to be 180 minus x, or again in this case 180 minus 45. So complement's equal to 45 degrees, supplement is equal to 135 degrees. So again, first part is picking out that keyword of is. Second part, go through, pick out what you know. Measure of any supplement. Some unknown supplement is 180 minus x. Complement is 90 minus x. Those are the hard parts. Then you have to fill in the extras. We're going to go over 9 and 10 tomorrow together. I'd like you to try them, see if you can work through them. If you get them right, that would be awesome. And then example 11 we will also do tomorrow in class in our groups, which will probably be a little bit easier than 9 and 10. I know these are difficult problems. You'll definitely see one on the test, so make sure you are able to do these. If you have questions on them, be prepared to ask them in class tomorrow.